Good afternoon, everyone, and welcome. I see that it is 3 o'clock, and I am very happy to have you here. My name is Joseph Boetes. I am the marketing manager at Cloudvisor and will be hosting today's workshop, AWS CDK from Zero to Hero Part 2. With me, I have Laimonas Sutkus, the serverless evangelist and the CTO of Biomapas. We are very honored to have Laimonas with us again today and excited for the content that he's going to share. Laimonas, if you would like to say hi to the attendees.
Hello, everyone.
All right, we're very excited to get started. Just so you know, you are very welcome to post questions in the Q&A or the chat. We will address those during the workshop. Also, if you don't have a AWS training account and you would like one, we can give you access by emailing events@cloudvisor.eu. Then this event is being recorded and we'll share that with you after the workshop. Then for those of you who don't know about Cloudvisor, I would just like to tell you a few things about us so that you're better acquainted. Cloudvisor is an advanced tier AWS partner and we operate in the Baltics, Nordics, and beyond. One of the services that Cloudvisor present or have is AWS Resell. We work closely with AWS to support current and new AWS users. And by switching your AWS billing to Cloudvisor, you can actually get access to one of 4 benefit packages that best suit your business. These benefit packages are to observe your cloud performance. So our AWS experts have created a state-of-the-art monitoring platform that enables you to track the performance of your cloud services 24/7. The second benefit package is to donate 4% of your AWS spend to an NGO of your choice. And I need to clarify here, Cloudvisor will donate 4% of your AWS spend with no extra cost or effort from your side. Then the third benefit package is to modernize your infrastructure. Every time your AWS spend accumulates to $10,000, you can get up to 5 hours of our team for experts AWS advice at 0 additional cost. This also includes a yearly AWS well-architected review. Now, the fourth and very popular benefit package is to save on your AWS spend. You can get an immediate 3% discount on your monthly AWS spend and a 50% discount on the CloudFront service rate. So if your company is thinking about using AWS or if you're already using AWS, I strongly suggest that you inquire about these benefit packages. Then I'd also like to tell you a bit more about our loyalty program. Did you know that you can get rewarded for referring companies to Cloudvisor? So the rewards are calculated on the monthly spend of the company that you refer, and they range from 200 to 1,000 euros. And it's super easy. You only need to head over to the loyalty program page, which I will share the link with you after the workshop. And then you just follow the easy steps. Once the company that you referred has completed their onboarding, you will receive your prize. And then without further ado, Laimonas, over to you. We can start with the workshop.
Okay, thank you, Joseph. I have to immediately apologize for my interaction. You will observe glitches from my side. Please do let me know. I will try to switch my Wi-Fi network, but I hope so far is good. Let me share my screen as we always do. All right, I hope you can see that one. So welcome everyone to once again with Cloudvisor. This is a continuation workshop from the previous one, AWS CDK from Zero to Hero. It appeared that the previous workshop was quite lengthy. I have prepared too much material to cover in one go. Therefore, we are staging the second workshop, which is AWS CDK from Zero to Hero Part 2. And we will try to refresh a little bit of our memory of what we did previously. Maybe even what we will refresh memory what AWS CDK itself is. And we will try to continue where we left off previously. So if anyone wants to follow my steps and do according actions in AWS, I hope you have your AWS console opened, and please follow me to. I think I'm not sharing anymore, or am I?
You are still sharing, Laimonas.
Yes, I am. Yes, I am sharing. Awesome. Okay, so please do follow me to GitHub page, and 1 second. Yeah, so github.com/Laimonas Sutkus. I will try to post it here. I heard the reply from Jonas that video, especially and audio, is lagging sometimes. Is it very severe, or is it just inconvenient? Okay, allow me to continue. If it will become like impossible, I will try then to simply switch my network. Okay, so please go to /Laimonas Sutkus, and here is the workshop material called AWS CDK serverless. You can go simply to repositories and simply git clone the workshop material. Once you do that, we can open the presentation and refresh our memory a little bit on what AWS CDK is and how to start with that one. So AWS CDK is infrastructure management tool, something like Terraform or CloudFormation. Could be compared to tools like Troposphere, but it is my personally favorite tool on infrastructure management in AWS Cloud, especially because it allows to write to define your infrastructure with programming language, not some JSON or YAML, but actual programming language. And Python is my always #1 choice when it comes to software development, and CDK supports Python very nicely. Some prerequisites. So in order to install CDK, you need Node and npm. It is because the CDK CLI itself is written in TypeScript, I think. Then depending on what language you choose, so for example, I chose Python, so you need obviously Python interpreter. At the same time, if you're making web-based applications, HTTP debugging tools, something like Postman is a really nice thing to have. And lastly, Docker. Docker is going to be used to build our Lambda code. And its dependencies, like it is not a necessary prerequisite if you don't do this step, but I highly recommend you to have Docker in place. So to install AWS CDK, it's a pretty straightforward process. You simply run npm install globally AWS CDK. I'm giving you a demo in CDK version 1. But CDK version 2 was released, and it is already quite stable. So if you are completely new to AWS CDK and you want to start, I advise you to immediately install AWS CDK 2. There aren't that many fundamental differences between those two versions. So this workshop material is very much relevant. So yeah, after you install, you can create a new package, a new project, a new app, or however you want to call it. So you simply write CDK init and you specify a language. In our case, I will show you all the examples in Python. So you simply write -- language equals Python. Now, just for fun, just for refreshing our memory, we can try and do that. I'll just go to desktop, create a new directory, call like something like CDK test, go to CDK test, ensure that CDK is installed, like CDK -- version, I have it. And if you simply write CDK init and equals Python, it should work very nicely. It is going to create a project. And if we were to open that project, just to refresh our memory, let's say new window. This is all generated for us. So you have a virtual environment. This is Python related thing. You have two folders, one for source code and another for writing your tests. An entry point to your CDK-based application is app.py. In here, you create an actual CDK application. You supply a CloudFormation stack to that application, and you finally synthesize it. Why you synthesize it? It is because AWS CDK is a simple wrapper around CloudFormation service. You all know that CloudFormation only deals with either JSON or YAML-based templates. And these are rather computer readable, not human readable files. And basically that's how AWS CDK was born, right? To not deal with those templates. So after it is synthesized to a CloudFormation template, it is then sent to CloudFormation service itself, and then all the magic happens inside CloudFormation service. This is a configuration part of your application. I'm not going to dig too much because now it's like very, very specific and niche examples. Finally, you have some dependencies. For example, for every single service, like Lambda, API Gateway, DynamoDB, RDS, you would install a related dependency. However, there is a change in CDK version 2. You no longer need to have those individual packages. Everything is nicely bundled under one single package, which makes your project development way more convenient. Now there is less chance of having dependency issues, dependency clashes, where, for example, you installed the Lambda package version 100 and it installed some dependencies like AWS SSM package version 120, and now those versions are for some reason incompatible, and you scratch your head wondering why you get these weird JavaScript, TypeScript errors, what is happening. And at the end of the day, it's just a minor dependency version issue, and that's it. So version 2 of CDK has nicely fixed that problem. Yeah, and basically that's it. If you go to source code, where we are defining our CloudFormation stacks, By the way, this CDK test stack is being initialized in our entry point, like you initialize an object out of this class. And here inside you create your resources, whether they would be Lambda functions, DynamoDB tables, or anything else. In this automatically generated example, we have SQS queue. SQS stands for Simple Queue Service. Like it's like an AWS way of messaging message broker. And as you can see, it is as simple as simply defining like queue, giving some parameters, something like visibility timeout, and so on. Basically, that is it. I hope it refreshed your memory a little. Going back to our big project example, please go to source code, because all others are just simply collection, for example, of postmaster actions. It contains the presentation, but what we are mostly interested is, of course, the source code. And inside the source code, we have very similar structure. We have the infrastructure source code itself. Then we have a folder for tests. But you will see that there is another folder called AWS CDK Layer. And we will come to that shortly. So I think the best way of us understanding how layers work is to do everything from scratch. So what I would do is I will try to simply delete this folder. And well, if you're following along, simply try to delete that one. And we will make it from scratch. Now, cdk.out is automatically generated directory once you try to deploy your application. So since before the workshop, I tried to deploy my application and ensure that everything works nicely. This folder was created for me, and I will delete one because it's not necessary. And as you can see, again, app.py is an entry point, very similar to our automatically generated one. CDK JSON, basically the same configuration. The only difference is in our dependencies. So since this is a way bigger project, we have more dependencies like Lambda functions, DynamoDB tables, and SSMs, which stands for Systems Manager, Systems Manager service. We have two more weird dependencies of Python. These are Python-based dependencies, attributes and C attributes. This is weird because if we don't have them, just GitHub CI/CD actions simply crash for some magical reason. Seeing a lot of complaints in the community. Not sure whether GitHub is going to fix those, but well, it is what it is. These two will definitely help you to solve your problems within GitHub Actions. At the same time, we have third-party dependencies like DynamoDB and requests. I'm sure most of you are familiar with what requests are. It's just a very convenient way of sending HTTP requests. Built-in Python libraries are not that comfortable to use. I think request libraries is the most convenient one. And DynamoDB is something that we will talk about later. It is an object relationship mapper for DynamoDB tables using Python. Very interesting stuff. And lastly, we have biomapas related dependencies. So as some of you might know, Biomapas is open sourcing quite a lot of software and putting to GitHub. So if you go to github.com, for some reason it's very slow. So /biomapas, you would see that biomapas itself has 29 repositories, and mostly all of them are AWS CDK based and written in Python. And these libraries are created to alleviate some headaches and some pains in infrastructure development with CDK, because, well, some of the functionalities are just simply missing or not convenient as they could be. For example, this is one of my favorite packages. It allows to very easily install Python-based dependencies into your Lambda functions. So if you want to create a Lambda function that not only does some standard stuff with the built-in libraries of Python, but you want to use something more, for example, if you're dealing with JWT tokens, you want a Python dependency called Python-Jose, I think that's how it's called. So using this layer and specifying a Jose dependency is simply like one line of code to adding this dependency to your Lambda functions. And I will show you everything in the very near future. So we have quite a lot of dependencies, well, quite a few. The layer is what I mentioned here previously, is just to supply dependencies to Lambda functions. Then we are using CFN API version 2, which is a very convenient way of creating API gateway version 2 HTTP APIs. It's bundled with some authorizers like Cognito User Pool Authorizer and API Key API Secret Authorizer. Extremely convenient stuff, comes out of the box. Then we have Lambda integration. This is HTTP related stuff. Well, I would say it is API gateway service related stuff. This is how you create your endpoints. Well, nothing very interesting about this library. But lastly, we have AWS-based testing framework. It is based on PyTest library. And what it allows us to do is to write integration tests for our CDK-based applications. Because as you define your infrastructure as code, obviously you want to somehow test it, right? The only correct way to test your infrastructure's functionality is to deploy it, run some tests against it, and then simply destroy it back. So you absolutely know that deployments work, destruction works, and lastly, the configuration of your services also is good, and it does what it is supposed to do. All right. So that's that about the dependencies. Since I have deleted this layer folder, I think we could go to AWS CDK serverless. Yeah, so to AWS CDK serverless stack. This is the entry point of our application. We can simply delete that layer and delete the instance and simply not supply any layers to our Lambda functions. So this is around where we left off in our previous workshop. we were set to create this kind of infrastructure. Well, but obviously we didn't have enough time to do so. So what we were able to succeed in, we were able to create an Amazon API Gateway HTTP API, which is defined here in api.py. You create an API, you specify that it is an HTTP API, you give some coarse properties like allowed methods, allowed origins, allowed headers. You enable staging, and finally you build some routes like create route, read route, update route, and delete route. Well, it's a basic HTTP CRUD API. And this is what we were able to achieve: create endpoints. Every single endpoint should be backed by a Lambda function, like a nano service. And I believe we were also able to create a DynamoDB table, which again simply looks like this. We simply inherit from the AWS DynamoDB table, and we define a little bit of our own properties. I see one question in our chat. So I see the conflict is caused by the user requested the Lambda depends on because I'm using CDK. Yeah, so Jonas is having some conflicts, and there can be two types of dependency conflicts. So if you're using CDK version 2 as your CLI, this project will not work for you because it still uses these version 1 based dependencies, right? This is one reason. Another reason is less serious. So if I would try to source, wait, I go back, source virtual environment bin activate. And I would try to install pip install recursively source code requirements.txt. I would see some of the incompatibilities, as you can see in our packages, like custom API key authorizer requires CDK parallel to be not more than 3, but you will have, or more than 2.2, but you will have like 1.3, which is incompatible. But this is nothing serious. This will not affect health of our project in any way. But yeah, Jonas, you need to use CDK version 1 if you want to be able to successfully deploy this project. All right, going back. So this is the definition of the table. The name of the table is cat table. We're creating some kind of cat CRUD API. I guess this is the most generic example that I could think of. For partition key, it is simply the name of the cat. I hope you can't change the name of the cat. Well, I assume so. We use default encryption. So we will use AWS managed KMS key. And finally, for removal policy, if we were to destroy the whole application, CloudFormation would destroy this database as well. However, if we would choose something like retain, even after destruction of our whole application, the cat table would still remain intact. And this is very useful for production-based protection. because you don't want, because even though, imagine you accidentally delete your infrastructure in production, all the services that hold data, something like DynamoDB, RDS, S3, would not be destroyed because of this retention policy. But I like to keep my infrastructure clean, so I always use removal policies to destroy everything after I'm done playing with infrastructure. Okay, so this piece of code represents DynamoDB table. As well, you can see that we have lines going from Lambda functions to DynamoDB table. You can think of those lines as integration or ability to access that resource or invoke that resource. Well, as you have, I guess, played with AWS for quite some time, you might have observed that almost every compute resource in AWS, whether it would be EC2 instance or a Lambda function or ECS container, they do have roles. And inside those roles, you can define what your instance can do against other AWS-based resources. So for example, if we have Lambda functions, out of the box, they don't have any kind of access. They cannot access DynamoDB, nor layers, nor nothing. In order for those Lambda functions to access DynamoDB, you need to give them explicit permissions. And those explicit permissions are defined in backend.py. This class is a simple wrapper around original AWS Lambda function because all of our Lambda functions use pretty much the same handler, pretty much the same runtime. They all need to have an invocation permission. If we are missing this permission, API gateway service will not be able to invoke Lambda functions. And all of my Lambda functions want to have a dynamic access to DynamoDB table, like table name and table region. And this is where granting accesses is defined. So I have created two methods. One is grant read, and another one is grant write. And write actions are considered as put item, delete item, update item, and batch write item for a specific cat table resource, of course. And lastly, read actions are considered to be describe table, get item, scan, and query. Of course, there are more actions, but creating these HTTP APIs, we are mostly interested in these DynamoDB-based actions. And how we apply those permissions to Lambda functions, well, this is very easy. If you invoke this function, what it does, it adds to role policy these actions. Simply, this is the magic line that allows your Lambda function to do something. And how it looks in the real code, well, as you can see, we create for example, our Lambda function. We give it a name. We specify what its source code. And this is where we specify that we grant all the previously mentioned read actions, and we grant write actions. I like this chaining functionality. For me, it looks pretty neat. And you achieve by simply returning self instance. And because of this, you can simply chain those calls and still be able to save that instance to a variable. This is like a small, neat trick that not everybody likes. Anyways, so read-based Lambda function obviously needs the read access, right? Update-based Lambda function needs both read and write because it needs to firstly get that item, modify with new values, and write it back. Delete, in theory, would only need the write action because it just simply tries to delete. But if we want to check before deleting whether that item existed before, well, we need the read action because we might want to try and retrieve before deleting to ensure it exists, because if it didn't exist, we might throw some kind of exception that, look, you're trying to delete an existing resource. Okay, yeah, and I missed the most important one, the create backend. And again, for example, before creating, we might want to try and retrieve, because if you simply write to the database, the way DynamoDB works, it will simply override your previous entity, and you will never know whether it was overridden or created like a new one. So again, it's a good idea to give for the create backend read action just to retrieve the entity or check whether that entity exists or not. So that's pretty much it. Of course, we can take a sneak peek into the source code of every Lambda function because, well, as you can see, we are defining the code with one line, code.fromAssets. You define the root, I think it's there. Yeah, I import this path, and I simply specify that it is a create folder, read folder, and so on. So if we open create source code, we will see that we have something like an entry point. This is how Lambda functions work. Every time you invoke a Lambda function, it invokes Python function, and it gives event and context variables. In this way, in this specific example, we expect to retrieve an event that contains a dictionary, and the dictionary contains a key called body, which well contains itself an HTTP request itself, like HTTP body, sorry. And there we expect the body to contain name, age, and color. And this is where we would use that DynamoDB ORM, but since we have deleted that layer, the Lambda itself should not work. But it's fine. We will try to create that layer and play with the API. Okay, so I think that's pretty much it. What we can do is now try and deploy it. Before you deploy, if you have a new AWS account, simply write CDK bootstrap, which will create a CDK toolkit, which is, well, no, kind of pre-configuration before using the AWS CDK itself. Now, in order to do that, I need to go to the source code and be in the same directory as the CDK JSON and app.py is. And once I'm there, I can write CDK bootstrap and It should take a couple of seconds. And since I have bootstrapped before, so we have everything working. I see another question in the chat. Jonas is asking, could you just show which versions of CDK you have? So if you go to requirements.txt, you have these. Simply install it. And if you go to the terminal and you go like cdk --version, I'm currently rocking a 1.157.0 version. To install the latest 1 version, you can simply run something like npm install global AWS. I think it's underscore or just simple hyphen AWS CDK at 1.x. And the X means any version after that. Let's see if that works. npm install -global. Yeah, I think it works. Okay, so yeah, the run was successful. And let's check it. Maybe I even accidentally upgraded it. So previously it was 1.157. Now it's 1.158. I guess this is not a breaking change. So did I answer your question? Okay, moving on. Since we have successfully bootstrapped the whole application, now we can simply write cdk deploy --all. And it will deploy all of our AWS CDK stacks. Now, as you can see, it asks us like, are you sure you want to create these roles and attach to these Lambda functions? Yes, I am aware of everything. And I simply check yes. Okay, and now it is publishing the CloudFormation template, and it already did. And now CloudFormation service started provisioning our defined resources. If you go to AWS console and we go to CloudFormation, my internet is slow today. By the way, am I still lagging to you, or did the situation got better? Better. Okay, thank you. So if you go to CloudFormation service, you see that this AWS CDK serverless stack is under provisioning. We can go to events and see that a lot of resources are being either created or are already created. By the way, if you go to app.py and you see that I gave this AWS CDK serverless stack name, this is exactly the same name in your console. So this is how you can easily backtrack your changes if you have hundreds or maybe even thousands of CloudFormation stacks. Okay, and I think it's done. So it's successfully deployed. If we refresh, we should see that it also completed. Okay. Sharunas is asking that he gets an error, module not found error, no module named AWS CDK serverless layer. The reason for that is if you go to AWS CDK serverless stack, you did not delete some line of code that I previously deleted, because at the very beginning, as you can see, we have only 2 directories. I deleted the layer because I said that we will do this from scratch. And that layer was used when creating backend functions, like it had the layer here. So you should just simply remove an import, which was somewhere here. And it should all work fine. Please let me know if you managed to fix that. Yeah, okay, it works for Sharunas, so we can continue. All right, what we got is, let's go back to that visualization. So what we got is the API gateway, endpoints, and the DynamoDB table. Let's try and check the API gateway. So if we go to API gateway, we see a new cat API that was created today. Well, of course, we see some configurations, but most importantly, we see an invocation URL. So we can copy that, open the postmaster, and we can try to send some HTTP requests. So I have prepared create, read, update, and delete. By the way, if you want, again, to follow me in the workshop material, there is Postman folder. You can simply import this JSON collection and we'll be able to do same things. So let's simply try create it. I will delete this part and replace it with the new endpoint. So //create obviously represents /create represents this route. Okay, but if you might guess, this will not work. It should result in HTTP 500 internal server error. And the reason behind this is that we deleted that layer, which contained the DynamoDB or object relationship mapper. And we didn't change the code itself of that Lambda function. So if we go back to that API, let's duplicate that. And we go to Lambda. And we go to create. You see that it tries to import that cat model, which is based on DynamoDB. We can try to simply, okay, JSON is fine, but we can simply hide that part, hide these parts, at the same time hide something like that, and simply return the dictionary of status code 201, and to specify that it is not base 64 encoded. If we deploy that Lambda function, which doesn't do pretty much anything, and we try to send another request, you can see now that it was invoked successfully and it returned 201. Okay, so we can assume that at least the configuration of infrastructure is correct, because API gateway endpoint can invoke Lambda function. That Lambda function can generate a result, give that result back to endpoint. That endpoint will get that result to the API gateway service. which is going to interpret that result and give the request back to the requester. Okay, so far so good. What we can now try is this part, the Lambda layer part. And Lambda layers are a very nice way of sharing code between Lambda functions. And the code can be any custom source code, or most importantly, a dependency. So for example, like Python-Jose or PyNamoDB is something that all Lambda functions would utilize. Going back to our project, this is what we want to create. So let's, in the source directory, let's create a new folder. Doesn't matter how you're going to call it. Let's say, okay, so since we are using this level of import, I don't want to change the source code of Lambda functions, so I will keep using that name. AWS _CDK _serverless _layer. Okay, fine, add it. And I will create a new folder. No, not folder, Python file called layer. As simple as that. Now, thanks to Biomapa's open source packages, I can create this layer very, very easily. So simply by importing from B CFN Lambda layer dot Lambda layer import Lambda layer. I'll just check if everything is as it should be. Yeah, this is the correct version. And I will create a wrapper class called, I don't know, workshop layer, right? And simply create a constructor which would expect CloudFormation stack, name of the layer, source path, and code runtimes, and well, basically some other configuration. Let me quickly import missing libraries. Okay, and now if you go to the documentation, like what the constructor does, it accepts scope, name, source path, code runtimes. It very nicely accepts the dependencies, which is a dictionary of key and value pairs, right? Where key is the dependency and value is the version of that dependency. And this is what we're going to utilize. Let me make that code a little bit tidier. And here I will say dependencies. It's a dictionary. And this is where I'm going to write PyNamoDB. By the way, if you want, okay, this Zoom thing, PyNamoDB to Python package index. You can find it here. The whole documentation. And it's a Pythonic interface for Amazon's DynamoDB, like how to install it, what are the latest versions, how to create a model, and so on. So let's use PyNamoDB. And now it expects a package version, right? Package version can be either latest. At some points, you might want to specify that don't install this dependency, like writing tests and so on. But most of the time, we are going to be interested in string representation. Going back to the docs, we see that the latest one is 5.2.1. And this is what I'm going to specify. And that's it. I don't need to worry about pip installing it, bundling it, uploading it as a zip file, then attaching to a Lambda function, all that nasty stuff that you would need to do if you were using CloudFormation templates directly, right? It eliminates so much of your headache that it is amazing. It is a no-brainer to use this wrapper. It saved to me countless hours of configuration. Okay, so we have specified the dependency. Now we can, instead of taking that name, we can simply specify it. Workshop layer. I think this is a good name. Whoops. So let's make all of our parameters named, scope included. For the source path, so layers can not only include the dependencies, but they can also include some source files. We will use the same folder to add new custom code that will be shipped alongside Lambda functions. So I will create something like cat model. What was that name? Yeah, cat model. Cat model.py, and inside that I will have a cat model class. And for the record being, it will not do anything. Let's create a simple dummy method like hello, and what it will do, it will simply print hello world. Again, very very generic example from me. But now we have created this one. Yeah, we need to specify the path. The way I like to specify the path is going to init file and creating a variable called root, or well, anything you prefer, guys. And the root is going to be an absolute path of the current directory in which current file resides. So this root variable will return me an absolute path to this folder. And now this is very, very nice and dynamic, because I can move this folder around and I don't need to change other parts of my code, because the root variable will always return the correct path, and this variable is importable. So now I can go to the layer and simply do something like from current path import root, and I just made my absolute path Python importable, right? So this is a nice, neat trick, which works not only in obviously the AWS CDK paths, but in other projects too. And that's it. So instead of source path, I'm giving root. And this is also no longer needed. And code runtimes, again, we can specify it as a list of runtime. And let's say it will only accept Python 3.9. And everything else can be simply deleted. So when creating this layer, we can simply supply the stack, the CloudFormation stack. So this is all we need. So let's go back to our main stack, which is AWS CDK serverless stack. And let's create a layer here. What? Let me copy that and create the workshop layer, import it, and it requires scope, which is current scope or current stack. Okay. And now now giving that layer to Lambda functions is very easy. You just simply give it to the constructor, like supply it like that. Or once the Lambda function is created, like the object is created, you do something like create dot, add layers, and simply specify the layer. So either this version or this version, they both work the same, however you prefer it. I think I prefer it this way. Okay, so create function, read function, update function, and delete function should be allowed to access that layer. Okay, and once we have specified everything, I think that's it. We can simply try CDK deploy it. Let's see what happens. Okay, so as you can see now, this is the reason why I told you that Docker is a prerequisite if you want to bundle shareable code for Lambda functions, because this CFN Lambda layer uses Docker under the hood to do all that heavy lifting, to install dependencies, package them, and do other I would say magic stuff. Yeah. And since the code was bundled, as you can see, the layer is given, the dependencies are installed. You can see PyNamoDB. We see more dependencies because most likely the PyNamoDB depends on these other libraries. And if we go down, we see the change set being initiated. Let's go back to CloudFormation. We see it. Is it complete? No, it's still creating the change set. So yeah, only now it started. Let's try and refresh. And well, as you can see, there are quite a lot of resources to be refreshed. Okay, and it will take quite some time. Well, not that long, a few minutes, I guess. So as it deploys, you guys can ask me questions. Please don't hesitate. I love answering questions. So the more, the better. So as it deploys, we are almost done with our infrastructure, right? We created those Lambda functions, and now all the Lambda functions share a Lambda layer. The Lambda layer contains the PyNamoDB object relationship mapper, right? I guess the only thing left to do is to ensure that all Lambda functions have good source code, they can access that dependency, and they can actually do something against that DynamoDB table. So as I was speaking, the deployment successfully finished. And if we go to that Lambda function, okay, so since we didn't change anything in the source code, it didn't touch it. What we can try now is we can try to import this cat model, and hopefully it works. So I will try to simply uncomment this line, and it should be all good because the name of the directory is the same. Then we have cat model, and inside that cat model, we have a class called cat model. Let's try that. I will try to, okay, let me just simply try to invoke it. Test, I will give some random key value pairs, save it, and simply invoke it. And as you can see, it actually succeeded because now it tried to parse the the event variables, and it crashed on this part. So it means that it was able to successfully import that cat model. Now, if I were to comment out both of these lines and try to invoke that cat model, which should be something like that. Allow me to deploy it really quickly. All right, and if I run it, you can see that it has successfully printed hello world. So as you can see, Lambda function doesn't have that, but it receives this dependency from a Lambda layer, which, well, I guess you can see it that it is attached here. However, the AWS console does not allow you to review the code. It is the limitation of the UI, but it's fine. I mean, if we go like infrastructure as code principle, we can always open that layer and see what's in there. So as you can see, everything works as expected. Now, the last thing to do is to create an actual PyNamoDB model. But this is where I am a little bit too lazy to write everything from scratch again. So this is what we're going to do. I see that we have modified some layers, some stacks, models, and so on. So we'll add everything and simply git reset. That's it. Thanks to Git, we can always go to original version of the project. And as you can see, nothing much has changed. We still have the layer. Instead example layer, well, instead of what it was like workshop layer, right? This is how it was called. Yeah. So to avoid any clashes, I will rename it back to the workshop layer. Nothing has really changed. This is the same PyNamoDB dependency. The only thing that has changed is the cat model. And as you can see, there was not much to configure. So what I'm doing here is I'm defining the model, giving some metadata like table name and table region. So the PyNamoDB engine would know where to go. And I'm giving a few properties for the cat, something like name, age, and color. Now you can go again back to the documentation. This is, I would say, a very similar example where we have email, first name, and last name. So very, very similar approach. So this is the cat model. If we go here, I think we can review Lambda function one by one later. So just simply try and deploy everything, and let's just hope it won't clash because of some naming. But It shouldn't. Everything should go fine. Okay. Think everything here is nice. So guys, I don't see any questions or comments from you. So are you following? Are you listening? Or are you simply sleeping? Going back to the cloud formation, again, if we refresh it, okay, it didn't start yet. It is still uploading. So give it a few seconds. Now, since we didn't update in the source code the source of the create Lambda function, it will not update, well, the source code because it didn't see any changes, right? But what is, again, really nice about cloud formation and CDK is that even though it calculates the differences in your Lambda function source code, and if it sees any changes, it will update that Lambda function with newer source code, which is very nice and convenient. But since we didn't change anything, I will do something like simply copy it, paste it back, and deploy it. Of course, it will not allow me to do so because the CDK serverless stack is being deployed right now. We will do that after it succeeds. Which shouldn't take very long, I hope. Okay, Jonas is still stuck in the dependency hell. CDK CLI is now version 1, but still getting dependency conflict, sadly, when running pip install -r requirements.txt. Are you getting the same error like mentioned previously? The user requested CDK Lambda 1 CIF and Lambda layer depends on because so is the pip install actually crashing, or you're just getting some errors? Because as I showed you previously, that some of the conflicts are fine. They can be simply ignored. Okay, so still waiting for the answer from Jonas, but we can continue with our workshop. As you can see, everything deployed quite nicely. Let me go back to the functions, to the create function. Oh, it actually updated my code. How convenient, very nice. So let's go back to the Postman, and we are invoking the create endpoint, and the create endpoint expects name, age, and color. And if everything is fine, then we will create a cat model, put those values in the model, and save it in the DynamoDB table. All right. Fingers crossed. Let's try to send the HTTP request. Obviously, we got some kind of weird error. If you get any sort of errors, you go to monitor vlogs in CloudWatch, because this is where all Lambda functions put their outputs. Let's quickly try and investigate of what went wrong. So object has no attribute hello. I guess I didn't employ it. Yeah, I need to deploy it. So Sorry for the confusion. Actually, CDK did not update the code. It was just my browser that kept this code in place, which was not deployed yet. So now I deployed it and back to normal. And I guess let's try to do it one more time and see whether it works. Okay, as you can see, it worked. It returned to a 1. Let's go to DynamoDB. And check whether that's our beautiful cat was created or not. Go to tables. As you can see, we have cat table. Click on explore table items. And well, surprise, surprise, we have a brown Tom of age 9. Oh, that's a very old cat. Let's try to create something else, like, I don't know, Muri, which is very young and is white. Great. Again, if we run a scan, we now see we have 2 cats. Okay, so far so good. This is our Lambda function that creates cats. Now let's try to go to the read endpoint, read Lambda function, and see what it does there. Again, sorry for my slow internet, having problems all day. So what now it does, again, it receives the event. It tries to parse query string parameters. Well, this is a query string parameter, like you see region equals EU central 1. This is an example of query string parameter. And in those query string parameters, it expects a parameter called name. And it will try to get the cat name. And it will return a serialized dictionary, JSON serialized dictionary with name, age, and color. Let's try and do that. I will copy the changed URL, or actually I can simply copy just the ID. Nothing else should change. And now the name is Tom. Let's try sending that request. And as you can see, it gave us the Tom back. All right, so this is how getting data from your DynamoDB with Pynamo object relationship mapper looks like. One thing that I really like about PynamoDB is that it abstracts the Boto3 SDK library, which is quite low-level library, and it forces you to play with those JSONs and marshalized data types. Yeah, it's ugly, it's inconvenient, and using something like PynamoDB is I mean, like, blessing from heavens. Anyways, let's try and see how the update action looks like. Okay, so again, we expect to receive the name of the cat because this is our primary identifier of the cat object. And we have 2 properties, right? Age and color. And if we don't set them, those won't be identified as an update action. But if we do set them, then, well, it will change those values. So let's go to that update endpoint. So, Tom is 9 years old, okay? Let's say that Tom, after a year, got older and now is 10 years old. Send the request. Again, HTTP status 200, okay. If we try to read Tom back, Now we see that it aged by a year. So this is how the update looks in Pynamo object relationship mapper. You create update actions. So for example, if age was specified, you append to update actions cat model dot age dot set and then an actual value. Same thing goes with color, like cat model dot color dot set, and you supply an actual color. Good. And last but not least, I guess, is the delete function. And it is a pretty straightforward. Again, it expects to receive the name of the cat as it is the main identifier of the entity. It creates a cat model and then it tries to delete one. The reason why it's not static, I assume it tries to retrieve it before deleting. Actually, not sure about that, but let's try to delete Tom one more time, like single time. Oh, sorry, bad API ID. So let's try to delete Tom. Let's say it got very old and died, unfortunately. Let's try to delete it once more. Okay, so it doesn't really check whether it exists or not. So if we wanted to create a really nice, robust API, what we would do is we would try to, let's say, cat model dot get, and we would put the name, something like that. Let's go to that read and see how it tried to, yeah, cat model dot get. So just by simply having this line of code should prevent us from trying to delete unexisting or no longer existing cats. Let's try that out. And it should be like internal server error because we are not nicely handling those errors. And we also had Muri. So let's try to delete Muri. And as you can see, it successfully deleted one. But if we try to delete one more time, now we get 500 internal server error. All right, going back to our visualization. I think we were able to achieve everything. We created 4 different endpoints for generic CRUD actions, create, read, update, delete. Those Lambda functions shared a base layer in which they shared a cat model, which is based on PynamoDB object relationship mapper library called PynamoDB. And we were able to execute all those 4 CRUD actions against our cat database and actually see that everything works quite nicely. Let's just try and run to ensure that everything was deleted. Yes, everything was deleted. So everything works. So that's a good thing. Now, if you don't have any more questions in creating this infrastructure, because I think now we are pretty much done in creating a serverless API using AWS CDK. And I would like to quickly transition to writing tests, actions, and other things. But as I see that we are already 1.5 hours past, and as I again see that there is quite some material to be discussed, I will not write those tests by myself. We'll look at the already written few ones and try to make sense of those. Okay, so going back to our project and going back to the serverless test, under integrations, we see that it is kind of a CDK application within CDK application, because we have our own entry points, we have our own configuration and so on. And once we creating this testing infrastructure, we want to be kind of separate from like an actual entry point. We want to have it like as a separate. So we have app.py, cdk.json, and this is very interesting one. It's called conftest.py. And if you have ever played with PyTest and wanted to have some hooks of your test execution, for example, before running tests, you wanted to create a database or some file or something like that, you would have a hook called PyTest session start. If you wanted to clean up after your tests, let's say delete items from database or from your temp directory, you would have a hook called PyTest session finish, all right? And in our case, before running tests, we want to deploy a fresh new infrastructure, then run tests against that fresh new infrastructure. And once all of our tests have finished, we want to destroy that infrastructure. And this is what like our AWS testing framework allows us to do very conveniently with one line of code. So simply PyTest session start is you prepare the infrastructure, and PyTest session finish, you destroy the infrastructure. I will not get too much into details. If one would go to, let's go to overview, and this is the testing framework. It has, I would say, a decent documentation. You would be mostly interested in testing AWS CDK based projects. And it has, like, as you can see, a preferred way of structure, like app.py, cdk.json, conftest. It's exactly the same of what you see here. It shows like how those hooks should look like, how app.py should look like, and lastly, how tests themselves should look like. All right, and let's have a sneak peek into some of those tests. So if we have something like create test, we want to send a request, an HTTP request against the newly deployed URL /create. And we want to assert that it was successful, like 201. If we want to delete it, well, we firstly create one, then delete one, again, expect statuses to be correct. Well, in order to have like fully bulletproof integration test in this point and this point, we should actually directly call DynamoDB with boto3, list or specifically get that item. For me being too lazy. Going to the read, of course, you firstly create one, then you try and get one and ensure that the data is what is well expected. And lastly, updating it, you create an entity, you get entity, ensure that data is what it is, then you update it, again, retrieve from new, and assert that, for example, color has changed from brown to red. Of course, we should go and understand what infrastructure.py is. It is basically, again, an entry point, a stack that is going to be deployed in test execution environment. And it simply creates this AWS CDK serverless stack and adds one output. The output is the API URL, because we cannot know in advance what the ID of this HTTP API gonna be. Like, it's randomly generated. So therefore, we need to save that one. And once we have saved that one in those tests, we can reference simply .get output. Again, this thanks to this testing framework, it makes it very easy to retrieve those dynamic variables. Okay, so this is how those tests look like. We can try to run them, but since this is the same environment, I will try and delete all of our application. It shouldn't take too long. And once it's being deployed, being destroyed, let's quickly talk about GitHub Actions and automating your CI/CD pipelines. So if you have your infrastructure defined as code, you can very easily maintain separate AWS accounts with the same mirror-like infrastructure configuration. You just simply need to execute this CDK deploy --all against any AWS account you want, and it will create an identical infrastructure for you. When it comes down to automation, obviously you don't want to run manually CDK deploy command. You want to automate that, for example, anytime the source code is merged to, let's say, something like dev environment or master branch, it would immediately compile and push code to your, let's say, production AWS environment or dev environment if it's like development branch. Again, we are not going to create it from scratch. I have an example. So if we go back to my GitHub page and we go to AWS CDK serverless, we see that I have created something like .github/workflows. And this is, well, GitHub's way of defining pipelines. So if I open that, like there are a folder within folder. And if I open main.yaml file, I will see like the whole pipeline defined. So this is where triggers are defined. So anytime I push anything to a master branch, this pipeline will get triggered. Okay. And once it's triggered, it will execute all those jobs in sequential order. So here we have 3 steps. Step 1 to actually check out the latest source code. Step 2 is to install the dependencies, like install the CLI and install Python-based dependencies. And lastly, we export AWS access key ID, AWS secret access key, and default region. Well, because obviously GitHub doesn't know about your credentials. You need to set them in your repository environment. And lastly, running pytest command to specific directory. In this case, it's under integration. So if you go here, it is under integration. It will see tests and it will execute all those tests. Okay. Let's go to CloudFormation. See, yeah, everything was nicely deleted. So I guess we can try and run the testing command. Simply write pytest, then AWS serverless test, integration, and it really doesn't matter if you go to integration or go to tests. Let's try this way. Let's see what it tries to do now. So I guess it's now bundling the source code of Lambda functions. if I open my Docker very quickly, we should see that in action. Okay, all the containers are done. Yeah, we see a new one was created and immediately destroyed. So we can assume that it actually works. And again, just for you not to stare at the blank screen where things are being deployed right now, I think we should see it in any moment. Let's go to our last important slide. And I guess this is probably the most important slide of the whole slide deck. Please do take a screenshot, for example, out of it if you didn't download the source code material, and especially if you're going to play with AWS CDK after this workshop. So these pro tips come from my harsh reality and getting stuck at random places and banging my head against the wall of why things aren't working the way they're supposed to work. So just by following these pro tips, you will save a lot of hours. And one more interesting thing is when you go to YouTube and you go to these AWS-based channels where they would show you how to deal with AWS CDK and how to create resources. Actually, I have never seen a YouTuber to talk about such pro tips. Maybe the reason is that they never played with the CDK so extensively. So I think in this slide, there is a lot of value where you won't even find in some like very, very famous YouTube channels. So let's get over this bullet list. The first one is be aware of stack limits. So a few years ago, AWS has bumped the limit from 200 resources per stack to something like 500 resources per stack. So this is less of an issue, however, it still persists. So if you can divide your application with different stacks, please do so. It will reduce the likelihood of you getting reach that ceiling of 500 stacks of 500 resources per stack. At the same time, if you use more stacks than one, you will be able to take an advantage of parallel CDK deployments. Well, currently CDK out of the box does not provide parallel deployments. However, going back to Biomapas, we have created a CDK parallel deployments package, which simply allows you to like a CDK deploy, very similar to CDK, but like A means asynchronous deployments, and it allows you to deploy all the stacks in parallel. So yeah, be aware of stack limits and put your application in more than one stack. Please do have separate stacks for your storage type resources, for example, DynamoDB or S3 bucket, because there will be times where you will want to refactor your application, change something fundamentally, and which will force you to tear down your application and redeploy it. In production environments, this is extremely difficult because now you need to back up your data. Then after deployment, you need to restore your data. This is not good. So what I found out throughout those years is that putting, let's say, a DynamoDB table in a separate stack, like single resource per stack, it's totally fine. will allow me to destroy Lambda functions, API gateways, and all the computing resources without destroying the database itself. And then I would quickly redeploy it, and everything magically works. No need to backup, no need to restore. So this is a nice trick, especially in production environments. Now, what you also would want to do is, if you have multiple stacks within your application, you would definitely want to reduce dependencies between those stacks. And having a lot of dependencies between stacks will hurt your parallelism. If every single stack is dependent from each other, then, well, you will not get any kind of parallelism, because it will need to deploy in sequential order, because A depends on B and B depends on C. So you need to deploy C, then B, and lastly A. But if you have, you know, like a nice branch, like tree branching as wide, then you can take advantage of parallelism. So this is one reason why you should reduce dependencies between stacks to a bare minimum. But there is another reason. Deleting manually your infrastructure, for example, let's say somewhere in the middle of your dependency tree, you want to delete one stack, which might be a single Lambda layer or simple Lambda function. You wouldn't be able to do that because it's like in the middle of your dependency tree. So you need to cut off all the leaflets, all the branches before you go to this stack. And now you need to delete this stack. It is painful, especially if that dependency tree is very big. So again, keeping dependencies between stacks to bare minimum will save you, again, quite a lot of time. And there are various ways of how you can reduce those dependencies, using strings instead of CloudFormation references, using SSM keys instead of, again, CloudFormation references. All those tactics can be found somewhere in the internet. People are using those strategies. Going back to the list, do not share Lambda layers between stacks. And this is especially painful one. So imagine in one stack you have 4 Lambda functions. In another stack you have also 4 Lambda functions. And in the third stack you have a Lambda layer. And then you reference that Lambda layer with all your 8 Lambda functions between your stacks, between your Lambda functions, right? This is what I said. Now, once you want to update that layer, for example, add a new function, whatever, the deployment would immediately fail. And the reason behind this is that you need to delete the layer before creating one. You cannot just simply update the layer. The way CloudFormation works is it deletes that layer and it creates the new one. Now, you cannot delete the layer because because Lambda functions depend on that layer. And you firstly need to delete Lambda functions. But since those Lambda functions are in different stack, the CloudFormation, well, how do I say that? Just simply knows that there is some kind of export or some kind of dependency to other stacks, and it cannot like start deleting Lambda functions in the different stack out of nowhere. So the deployment would immediately fail. And there is no simple way to work around that. You should only share Lambda layer between Lambda functions in the same stack. You shouldn't share that stack between different, you shouldn't share that layer between different stacks. Everything should be inside a single stack. Okay, another thing, using custom resources. Don't be afraid to use them. Don't be afraid to use custom resources because they are very powerful. You see, CloudFormation, with CloudFormation or CDK, you can't define every single resource in AWS. There are some missing resources. And to cover those, you would create something like a custom resource, which would be, let's say, backed by a Lambda function. And once it's invoked, it would try to provision some resource and simply return. So it is a very powerful way of adding your custom logic into CloudFormation templates. With that being said, you can actually even provision infrastructures within other SaaS applications. So for example, you can create a custom resource that creates a DNS record in your Azure environment, or creates a new workspace in your Twilio account, or even creates a Facebook post on your wall. I mean, the choice is yours. Yeah, but it just illustrates like how powerful custom resources are that are backed by Lambda function, because you can basically write your own stuff that is completely, it's completely custom, of course. Anyways, so don't be afraid to use third-party constructs, because there are quite a lot of them out there, especially from Biomapas and Identify, the two companies that I work with, and they both use AWS and AWS CDK. Because, well, those companies obviously faced some issues along this CDK journey, and they created those open source packages so you wouldn't have to face those issues for yourself. You can just simply install that package and use it out of the box. I talked about this one a little bit. So use asynchronous stack deployments. Again, it will save you a lot of time. Currently, only Biomapas AWS CDK parallel library supports this parallel deployment, not natively by CDK itself. And again, if there aren't that many dependencies between stacks and you have hundreds of stacks, like in some of our projects in Biomapas, you can reduce deployment times from something like 2, 3, 4 hours to something like 10 minutes. It is that powerful. So yeah, don't underestimate asynchronous deployments. I talked about this also. So if you have defined your infrastructure as code, you must use dev stage prod environments, and you should definitely automate the provisioning of your infrastructures through CI/CD pipelines like GitHub Actions or Bitbucket pipelines, or Jenkins Circles, Circle CI, how it's called. So yeah, you should definitely automate infrastructure deployments. And last but not least, and extremely, extremely important, if you're going to define your whole application, whole application, or whole project or product as a single AWS CDK application, you are going to have a pretty rough, hard time. Because as your application grows, so the length of your deployments, and it will sooner or later start feeling like a distributed monolith, which you want to avoid at all costs. So what should you do is you should define your project or product into different logical units of AWS CDK. I will give you an example. So most of the products require some kind of monitoring. Okay, so have a CDK app for that. Projects need some kind of notifications, like sending emails maybe, or sending webhooks. Have AWS CDK for that. You need, let's say, functionality for analytics. Have AWS CDK app for that. For example, you have some core functionality like business logic. Obviously, AWS CDK for that. You want to integrate telephony services. Have an AWS CDK for that. And by dividing your product into many separate lightweight AWS CDK apps will allow you to deploy those apps independently and test them independently. It will be much easier, much faster, and will require, well, less knowledge, and it would be less complex and easier on your eyes. So this is very, very important tip for you. Okay, going back to the PyTest, as you can see, everything has finished. Let's go quickly through that. Yeah, what's happening? So we see that test session starts. I think it at some point it deployed our infrastructure. I don't see where it was exactly. It found 4 tests passed, and now we are, I guess, destroying the infrastructure, and that's it. So yeah, this is the illustration of creating infrastructure, running tests, and then deleting the infrastructure. Okay, we covered that part. Okay, we went to the summary. So 3 bullet points. AWS CDK is a great tool to manage your infrastructure. If you haven't chosen something like Terraform or Ansible or Chef already, please do consider using CDK with your own favorite language like Python, Go, JavaScript, TypeScript, .NET. You should write integration tests to test your infrastructure instead of unit tests, because unit tests don't ensure that your infrastructure will continue to work. And lastly, don't be afraid, and I encourage you to use open source libraries, for example, like Biomappa's open source libraries to boost your productivity, like Asynchronous deployments, creating those Lambda layers with very convenient dependencies, and so on. Okay, so this workshop was a little bit more efficient. We fit into 2 hours. So everyone, thank you, especially for those who stayed up until the end. If you have any questions, shoot them out, or just go to Baltic's Slack channel. I think Joseph will tell you about that. So back to you, Joseph.
Thank you very much, Laimonas. And yeah, thank you for bringing us to true hero status with the CDK. We appreciate it. And thank you to everyone who attended. As Laimonas said, Laimonas also mentioned our Baltic Slack channel. I will include a link to that in the post-event email. And in that channel, yeah, it's a community of AWS users where we help each other figure out problems and share some of our secrets. So yeah, we really hope that you enjoyed this workshop. Please remember to have a look at our benefit packages that you qualify for when you switch your billing to Cloudvisor. And also don't forget about our loyalty program, where you can get up to 1,200 euros in prizes per company that you refer to us. So I will share the links mentioned with you along with the recording in the post-workshop email. Keep well, everyone.